All right, guys, welcome back to our second part of 5.1 or 5.5. And we're just going to go through three different examples today using what we have already learned. So, example three, if f equals 17 and d equals 32, find e. So, we have f equals 17 right here, and we have d equals 32. All right. And now we want to find E. We want to find this angle E right here. And how I'm going to do that is I'm just looking at this angle and I'm asking what trig function do I need in relation to that angle to find out what it is. And so for me, it's looking like adjacent over hypotenuse, which is cosine. So if we take the cosine of E, we're going to get adjacent over hypotenuse. Now, we don't really know what 17 over 32 is. That's not a nice one like square root 3 over 2, square root 2 over 2. It's not one of those nice angles that we recognize right away. So what we're going to have to do is we're going to have to take the cosine inverse of both sides. And so then the cosine inverse and the cosine kind of cancel out, and we're left with angle E equals cosine inverse of 17 over 32. And this is the type of thing that you just punch straight in your calculator. So on your calculator, you have to hit the second button, and it's above the cosine. So second cosine, and then 17 divided by 32. And then that's going to get us, I should say, about 57.91 degrees. And that's it. That's our answer. That one is that simple. Just put something in your calculator. So example 4, a security light is being installed outside a loading dock. The light is mounted 20 feet above the ground. So I bet we're going to make a picture. So I'm just going to say that's 20 feet above the ground, and here is our light. So that's 20 feet above the ground. The light must be placed at an angle that will illuminate the end of the parking lot. If the end of the parking lot is 100 feet from the loading dock, what should be the angle of depression of the light? So we're going out, and that needs to be 100 feet. Now, we have to be careful with the wording, right? We're looking for the angle of depression of the light. So when it says angle of depression, it means this angle right here, right? Which is the same as this angle. So we're really looking for this angle right here. And that's in the wording of the problem that we're going to have to get used to. But again, it's just something where we have to figure out the trig function with the angle we're working with. Let's call this angle theta. And so we have tangent of theta. And I'm just going to leave space because I know where this is going, equals opposite, which is 20, over adjacent, which is 100. And then to get the angle, we're going to need the tangent inverse of both sides. Those kind of go away, and we're left with theta equals tangent inverse of 20 over 100, which is the same thing as 1 over 5. But again, even though 1 over 5 is nice, that's not a nice angle, right? Tan inverse is asking whose angle has the ratio 1 over 5, and we don't really have those ratios. We have 1/2, we have square root 2 over 2, we have square root 3 over 2, but nothing is like 1/5. So this is another one where you just punch it straight in your calculator. So we're going to do tangent inverse of 20 divided by 100, and you could type in 1 over 5 and you would get the same thing. And then we're going to get that angle is about 11.310 degrees. And that is all for that one. Now, the second ones are really where these problems are at, and that is completely solving these triangles. So solve each triangle described, given the triangle at the right, and solving a triangle just means find all of the sides and all of the angles. So we know that A equals 33 degrees for this one, and we know B is 5.8. So first things first, we can find this other angle, right? All angles have to add up to 180 and one's already 90. So really, the two other angles have to add up to 90. So we know that this one is 57 degrees. So we've already found B equals 57 degrees. Already done, right? And now we just have to find the sides. I'm going to go for side A first. And I'm just going to use something that involves A. And we need to involve B because that's the only other side we know. So let's do tangent. And then if we do 33 degrees, then we're going to get opposite, which is A, over adjacent, which is B, which is 5.8. And then A equals multiply the 5.8 over. And when we punch that into our calculator, 5.8 times the tangent of 33 degrees, we get 3.767 rounding. And now we can use the Pythagorean theorem, right? Or we have two options. We can use the Pythagorean theorem because now we have this as, so we have A is 3.767. We have this other angle here. And now all we're missing is this side length C. And so we can either do that with the Pythagorean theorem because we have both sides. We have 3.767 and 5.8. Or we could use another trig function. Let me use another trig function just for fun. So I want to use, let's use 33 degrees again. And then we know 5.8 is more accurate than 3.767. So let's do the one that involves adjacent and hypotenuse, which would be cosine. So cosine of 33 degrees equals adjacent, which is 5.8, all over hypotenuse, which is C. And then we'd multiply the C over and divide by the cosine of 33 degrees. And when we do that, we get 6.916. And now we've just found everything in this right triangle. And it might be nice to write everything you don't know, right? So we have, we learned that B is 57 degrees. We learned that A is 3.767, and we learned that B, or not B, we learned that C is, what do we just get? 6.916. And from that, we have all the information because we were already given B, and we are already given the angle A, and we know C is 90 degrees. So now we've just solved the entire right triangle, right? We've found every angle measure and every side. And now it wants us to do it again. So we had our triangle here, and where did the order go? A, B, C, and then that would be B, this would be C, and this would be A. Gives us that A is 23, and C equals 45. So this time we start with two sides, And when I have two sides, immediately I'm just going to find the third. So I know that B, the missing one there, is going to be the square root Pythagorean theorem, 45 squared minus 23 squared. And I'm just going to use the decimal for this one. And that is going to be 38.68. And so now we have that side. And now we just have to find one of the angles. But keep in mind, this right here is an approximation. So when I'm looking for the angles, I probably want to use the two exact measures that I was given. So let's look for A. And if I'm looking for A, I'm going to want to use the two exact measures I was given, which is opposite and hypotenuse. So let's do the sine. So we have the sine of A equals, and I'm going to leave some space because I'm looking for an angle, and I know I'm going to need to take arc sine if I'm looking for an angle. Opposite is 23, and hypotenuse is 45, and then I know I'm going to need to take sine inverse, and so then A is going to be sine inverse of 23 over 45. Punch that in your calculator. 23 divided by 45. And we're going to get about 30 points, and I'll just round it here, 7 degrees. And then right away, then you already know what B is, right? Because that has to add to 90. So B is going to be 90 minus that, or 59.3 degrees. And there's those two, and B is nicely written over here. And so we're done for solving that triangle. And that's going to wrap up 5.5, which is solving right triangles.